Hi everybody, my name is Max Maker and this week I'm going to show you all the electronics that are going into my electric hydrofoil build. Last week I showed you the electrics, and these are all these big cables and the batteries of course, and everything was waterproof, but this week is all about the remote control and the communications. So this is the first prototype that I built of my remote control. I designed this in Fusion 360, and of course you could download the files and build one yourself. These are also quite useful if you want to write an e-skate with them. And this is the first prototype, so it wasn't perfect and I printed it again. What was wrong with this spring didn't have enough tension, and it was also a bit too flimsy. This was 1.2 millimeters in thickness, and later on I went to 2 millimeters wall thickness. But it gave me an overall idea of how it worked, and this is the second prototype, and this turned out really well. You see it's a little bit more refined, and these are all the electronics that are going to go inside. So what we have got here is two parts of the housings. This is the right housing. This is going to take the battery here at the lower half. Here in the middle is a space for the trigger. It goes in there like this, and we've got a little spring in there that's going to retain it. And above the trigger will be two buttons, which are these. They're going into these holes, and then one big button for the on and off switch. So at the heart of this is this Arduino Nano that's going to register if any of these buttons are pushed, and it's going to send these events to the board with this Wi-Fi receiver on the left. So the challenge now is to fit everything inside of here and make it work again. I already tested the circuit, so that works, but now obviously it needs to be reattached to these buttons. So I have to resolder these wires because you can't put in the buttons with the wires on. And I bent these down again so they're a little bit more compact. So if you never worked with Arduino before, you're probably wondering, how does this guy know how to connect all these cables? Well, you just look up a tutorial. This is a tutorial that I included in my code for the Wi-Fi module, and it tells you which cable to connect to which pin on the Arduino, and you just follow that. This right here is a little Wi-Fi module that I'm using. It costs like $2, and after I checked that all the connections are right, I just cover them with lots of hot glue because it's really unfeasible to put shrink tube on this. And also onto these resistors, basically everything that could short out to other components gets covered. So all the cables and components just about fit inside of this housing, and now I have the task of closing it. And if you've seen my videos before, you've probably heard me say that you always underestimate the space you need for cables. So it was tight, but it fit just about. I used really thin cables that I found inside an old SCART cable, because these SCART cables, they have like 20 strands or something like that, and they're usually a meter long, so you get a lot of cables in different colors, and they work really well for this Arduino stuff. And of course I forgot to put this trigger in, and this little spring is going to retain it to its original state, and the axle is just a cut-off nail. Later on I used a little bit more polished nail, and it goes in there like this, and then the spring is going to push it back out, and it's just about the right pressure here. So now the remote control is pretty much done, and you can also use this of course for an e-skate if you want. And special thanks to MAB from the eFoil Builders Forum, he helped me out a lot with the software for this. And now it's time to put the counterpart of this into the board. Alright, so let me quickly go through all these components. I know this probably looks quite complicated right now, but I promise you it's not really. It's straightforward. What you just have to do is take all of these modules that go inside, look up a tutorial. I've included lots of tutorials in the code itself, so you have some reference to how I connected things, and then you can just copy this basically. First of all, what we need is power. Obviously we only have these 37 volt batteries in there, 37, 44 volt batteries. So they are going to get power through these two cables. And they go through a fuse that's in here into this little controller, and this is from RC stuff. It's called an S-back. I think normally they're called U-backs, and this changes this 44 volt to 9 volts. So we've got 9 volts coming in through this line into this board. And first of all, what these 9 volts do is they go to power the LED strip, which is this little thing. Normally this is connected to a USB plug, and a USB plug needs 5 volts. So 5 volts I didn't have, so I put this in here, and it's a little voltage controller. It costs like $2 or so. This is how it looks like. That is in here, and then we've got power for the LEDs. But they are not important. What's important is here in the middle. This is the heart of everything. This is an Arduino Nano. It's not an original. It's like a knockoff, and this is going to control a lot of processes. First of all, we've got temperature control. So we've got these resistors here, or thermistors they're called. They are temperature sensors, and when the temperature changes, they change the resistance, and the Arduino can measure that basically. And how to connect them? There's a tutorial for that, obviously, on the internet. Really straightforward. You just connect them to the pins and then give it some code, and the code reads out what temperature you have. Here on the right, we've got two really big relays, and these relays are going to control an even bigger relay, which is going to turn on and off the main battery. So this is called the anti-spark routine. That's all this does. Down here we've got an RF24 Wi-Fi module. This is like the standard module that everybody uses on Arduinos. They cost also just $3. Everything here is $3 basically. That is cheap stuff. And this one is connected to the Arduino and is going to communicate with the remote control. So these two are connected. And down here we've got a display. This is a 16:2 display, which means you've got 16 characters along and 2 from top to bottom. And this is connected with a bunch of wires to the Arduino, and this is really lots of pins, but it's necessary to see what's going on inside. So let's turn this on. So what I'm using is this power supply right here. So let's connect this. There you go. Arduino is turned on. You hear the relays clicking and says batteries are connected. And now it shows me 4 temperatures. This is for the VESC, for the motor, for the batteries, and for the connector. So I want to measure the temperatures of the connectors at the beginning at least, and later on I can use this for something else. And this 1500 tells me that this has a signal from the remote, because the 1500 is like a signal that's going to be sent over to the VESC to turn on the throttle. So 1500 would be 0 and 2000 would be maximum. So let's see if that works. And there you see it's slowly going up to 2000. So now we're on full throttle and it's doing it slowly because it's ramping up. You don't just want to jerk the engine, you want it to accelerate smoothly. And if I let go, it should turn off straight away. It doesn't really do it straight away, there's a tiny delay. I don't know if you can see this. Turn it off now. It was like, and it's turned off. Alright, so I put everything in these IP54 boxes and these are going to be put inside the board itself. And the display was hot glued into the inside of the board. I also wanted to connect a little temperature sensor to the VESC, so I couldn't really attach it in any way, so I just clamped it in place with this little hose pin. Once that was done, I could connect all the rest of the cables through these cable glands, and this was really straightforward, easy work. But then the trouble really happened, because somehow I broke the VESC. A lot of people tried to help out, but couldn't really. So first I sent it to Dan from DIB Engineering in Holland, and he fixed it somewhat, but something was still not working. They couldn't get the PPM signal across. So then Flo helped me from the eFoil Builders forum. He modified my code to use UART, which is like a serial connection, which I really don't know much about. But in the end, Tramper kindly sent me a new board, and now I'm ready to test the motor. It should be set up correctly. Oh, and a big thanks to Wolfcraft for sending me these awesome clamps, they're really handy. So I went through the whole setup process on my computer, but now it's time to test it with the real batteries to see how much power this motor can deliver. So I set all of this up outside because there's always a risk of fire, and I was really nervous to plug in these big batteries. So I had a fire extinguisher handy. This is a CO2 fire extinguisher, so it won't ruin anything, it's just the gas that's coming out. And after closing the lid, I noticed that the display didn't work anymore, and I thought maybe this has something to do with the batteries, because I never tested them before, but it was only a wonky connection at the connector right at the top of the display, so I need to hot glue that in. But for now it works, and there you see it says no signal because the remote wasn't turned on. So let's get that, but of course first we need to make it waterproof. I'm sure you were wondering about this already. So I was in a supermarket and I found that they sell these rubber sleeves. I don't know what they use them for, but these are perfect to put over the remote, and that makes it waterproof. I might have to add a second one just for safety, because you don't want any leaks obviously, that would really ruin your day. So here's the neatly packaged remote, and I heard there are larger ones of these rubber sleeves available, but I'm not quite comfortable asking for them because I then have to explain my whole situation with the hydrofoil, and they probably won't believe me that this thing will fly anyway, so I just stick with this one now. So let's try out the motor. So first I press this little button right here, and this will power on the big relay and then power the VESC, so now I can pull the trigger. And after some time, for safety, this should spin the motor. And there we go. It actually spins. Really happy about this. This is all I wanted, and it was a long way to get here. I had so many issues with the VESC and with the Arduino stuff. I blew about 4 Arduinos in the process just because of my own fault. The VESC was broken once, it was sent to Holland, it returned. I had lots of help from the forum members, and I really need to thank them for this. This is really a community effort, and I know lots of you guys are curious to see me on the water, and I really hope I get going very soon. So next up is building a prop for this, attaching the prop, testing the prop in the pool, and once I've got enough thrust I can attach it to the board, and this is all the easy work, you know. Getting these electronics to work, this was really difficult. So I'm glad this is done now, and if you want any information on this, there will be an instructable for the remote control and the Arduino stuff as well, and there's also the code available. And you know, don't worry about all this stuff, it's all solvable. You just need to troubleshoot for a few months. Thanks for watching, guys. I hope I inspire you to make something yourself today. And as always, my name is Max Maker and I make all kinds of stuff. And here's a little extra for you. So let's say you made a little solder joint and you want to know if you did it correctly. So you just use your multimeter, set it to continuity and listen for the beep. So you want to connect the ground here to the minus pole and the positive to the VN. And if they beep, they're connected. If they don't beep, they're not connected. And you check this after every component you've added. And then it will work. And here's another pro tip from me that I learned from experience. Use these header pins to attach Arduinos and other chips, because then you can easily take it out and put a new one in, so you can troubleshoot if the Arduino is broken, for example. And sometimes you blow an Arduino. It doesn't cost much, it's $2, but you need to be able to replace it to even check if it's the Arduino that's broken or some wire connection.